Today's Daily Dose of Math is about regular polygons. What is a regular polygon? It has to have congruent sides and congruent angles. So to be regular, all the sides have to be the same length. And all the angles have to have the same measure. But the number of sides can vary. There are different regular polygons. The simplest is the equilateral triangle, and then there is the square. And these are the ones that have 3 sides and 4 sides. But of course there's the pentagon, there's the hexagon, and etc. I'm going to draw all of them from the triangle to the decagon. I won't bother with the nonagon. The decagon's already drawn here. So a decagon, it's called that because it has 10 sides, 10 congruent sides with 10 congruent angles, 10 congruent internal angles, and also 10 congruent external angles. But what I did here was I decided to draw a decagon with side length of 10 centimeters. So I started with one 10 centimeter line. I used my giant teacher protractor to draw angles. I did my best to keep all of the sides 10 centimeters in length and all of the angles exactly equal to each other. But what angle? What angle did I need to draw? Okay, that's the next thing we'll talk about. There's a little formula, which is n minus 2 times 180 degrees over n. When we do this, for instance, with the triangle, we get 3 minus 2 times 180 over 3. 3 minus 2 is 1. So we have 1 times 180 over 3. We have 180 degrees divided by 3, so 60 degrees. We knew that would happen because we already knew that an equilateral triangle is a regular polygon and has 3 internal 60-degree angles. If we do this with the square, 4 minus 2 times 180 over 4 is 2 times 180 over 4, which is going to give us 90 degrees. And of course, a square has 4 internal 90-degree angles. So we can do this with any number of sides. I'll do just one more, which is the decagon. 10 minus 2 times 180 over 10 equals 8 times 180 over 10. I'll do this quickly. 8 over 10 is 4/5. 4/5 of 180 is 144 degrees. So what I did to draw this was I drew a 10 centimeter side and then I drew a 144 degree angle. You can see the little dots that I put on the chalkboard with the protractor in order to find the angle I wanted. I drew a second 10 centimeter side. From that I drew another 144 degree angle. I just did this until I got all the way around. Now when we're drawing things in a math test for marks, most of the exams that I correct allow a plus or minus 2 degree margin of error on angles and a plus or minus 2 millimeter margin of error on side lengths. This would get quite a high mark, but it would not get a perfect mark because as I constructed it, I started here and I worked my way around, and when I got to the last side, I measured it and I realized it was only 8 centimeters long. So all of the sides except the last one are actually very close to 10 centimeters long. All of the angles are very close to 144 degrees. I think the only one of the sides where I would have to deduct marks is this 8 centimeter side, and I would not have to deduct marks for any of the angles. So that plus or minus 2 degree margin of error and plus or minus 2 millimeter margin of error is actually quite generous when it comes down to whether the teacher has to take off marks on an exam. But this is in a regular high school math exam. That's the type that I correct. If you're taking a drafting course, a technical drawing course, if you're on your way to becoming an architect, if you're going to design airplanes, then there's a good chance that you would be marked much more strictly on drawings. On the other hand, you're probably not going to be required to draw on a wall with chalk, because if I have to make excuses, that's my excuse for this not turning out perfectly. Okay, so I'm going to erase this, and I will list all of the polygons that I'm going to draw, including the decagon that I already drew. I'm just going to list the names of them and the angle measurements. So we have the triangle, and that was 60 degrees. We have the square, 90 degrees. We have the pentagon, and when you plug 5 into that little formula, you get 108 degrees. Hexagon, 120 degrees. Heptagon, which is the name for the one with 7 sides, 128.6 degrees. This is the only one where I had to do some rounding. Octagon was 135 degrees. Nonagon, and I'm not going to draw that one, was 140 degrees. And of course the decagon that I did draw was 144 degrees. So I'm going to draw all the rest. I've already drawn the decagon, I started my octagon, and I'm not drawing the nonagon. So this won't be too hard, but I'll use fast motion so that the video is not too long. Now, when I did the decagon, the first thing that I discovered was drawing one angle at the end of each line segment was slow. And I made that a little quicker when I started my octagon, and I'll show you how. Because, okay, I've gotten this far. I've drawn 5 of the sides. I only need 3 more. When I go to measure my angles, I need a 135 degree angle. So that's going to be here. I make a little mark. But I may as well do this one at the same time. So another 135 degree angle is going to be here. So these 2 little marks are going to be used to draw the next 2 segments, and I can just draw them 2 in a row. 10 centimeters in length. Very tricky with chalk. 10 centimeters in length, using that little mark I made on the chalkboard. And that means when I draw the last one, kind of like what happened here, I should be able to just connect the dots, and they should be 10 centimeters apart. Let's see how well I did this. Not bad, actually, not bad. I would say it's a little shorter than it should have been, but I fell within the plus or minus 2 millimeters, so I would not have to deduct any marks for this. Now also pay attention to the idea of labeling vertices and labeling angles. Depends on how the question is asked, what you're being asked to do, but if I'm required to label, then one thing I can consider doing is saying, well, I'm putting 10 centimeters to label a side, but because this is a regular polygon, it means all of the sides have to be 10 centimeters. I don't have to write it 7 more times. And therefore, same with the angles. The angle is 135 degrees, but I can also do this little shortcut, drawing my arcs on all the angles, and then using that little symbol that says they're all the same. I can try that. And then the side lengths. Well, all of the side lengths are the same, so I can use these are all the same symbol there too. It's getting a little crowded though. Okay, so we've drawn a decagon, we've drawn an octagon. I want to draw a heptagon, and that's what I'm going to do next. But I'm going to stop talking because I'm going to start doing it with fast motion. Okay, I did it. So that only took 20 minutes, but this is the regular pentagons. The important thing from this lesson really is, what would a student be able to remember how to do out of all the things that I've just shown? I think a student would probably be able to remember all of it quite easily, so long especially as the student makes sure to notice that this formula is extremely useful for being able to do all of this, to be able to find out facts that you need to know about the different shapes and to be able to draw them. That's today's daily dose of math.